Greetings, judges. My name is Rakha Robredo, and I study at SMPI Al-Azhar 13 Surabaya, and I will be present about my device that I created called Smart Band for Blind People to maintain a distance during COVID-19. And I will be participating at LPB Nasional 2020. This pandemic has forced us to do social distancing with each other. This may not be a problem for us, but this is maybe a problem for blind people. With their lack of vision, they must have a hard time to do social distancing. In this case, I'm going to make a device as a reminder of social distancing for blind people. This is what I'm working on. The device consists of BLE, Arduino, Wi-Fi barrier, and buzzer. The device always transmits and receives signal from the other device. Each RSSI is used to determine which device is closer, less than 2 meters. So the device will sound a buzzer or vibrate. This is the device. The reason why I make two of this device is for experiment. This device is not yet compatible to, to other device. So if the device gets closer, then one of these device will make the sound or vibrate as an indicator. This is the device. This is a flow chart. Firstly, the device will make sure if there is any device nearby. If there is no device nearby, then the device will turn into its normal state. But if there is another device nearby, then the device will start to calculate the RSSI. If the RSSI result is less than 1 meter, the buzzer and the alarm will active. And that's it. This is the hardware equipment that covers my device. So BLE 4.0, or known as Bluetooth Low Energy. Bluetooth Low Energy, or BLE, is the newest version of Bluetooth. It is cheaper, smarter, and requires low power. Arduino microcontroller to receive data from BLE and output in the form of vibrator and buzzer. Lastly, but not least, buzzer and motor vibrator. These components are the outputs. Buzzer and motor will activate when a device is close. This is the design scheme, electronic and board simulation. This is the scheme. Now, from left to right, this is the PCB before install and after it's installed. PCB is a printed circuit board. After installed, the experiment that we do covers 1. Experiment for activating the buzzer, 2. Experiment for activating the more vibrator, and 3. Set Bluetooth as a receiver and transmitter. This is the test. The testing for buzzer, the steps are define buzzer pin in Arduino, set buzzer pin as output, and set high or low for buzzer. The result is, if it's set high, it activates, and if it's set low, it inactivates. Testing for more vibrator. Steps are define more pin in Arduino, set more pin as output, and set high or low for motor. The result is, if it's set high, it activates. If it's set low, it inactivates. Testing BLE as the receiver. The steps are set pin BLE as transmitter and receiver, and then configuring 80 command so that the BLE can receive signal around. And that is the result. Testing the BLE as a transmitter. The steps are set pin Bluetooth as transmitter and receiver, and then configuring 80 command so that the BLE can transmit signal around with the UUID and set BLE as I beacon. And that's the result. This is the RSSI test with the distance of 1 meter, the result. This is the function test. And the conclusion is that physical distancing or social distancing is needed by all of us, including blind people. With this device, blind people were able to maintain a distance with each other. And this is not the end of the line. The device that I created was only compatible to certain tools, but in the future, I'll make it compatible to any type of device, and will continue to research about the other function of this device. Thank you, and I hope this device helps many people.